Welcome back with Mrs. Ma Abdulrahman, science teacher. We are going to learn about graduation of the properties of elements in the modern periodic table, and we will know that there is a relation between these properties electronic configuration of elements. First of all, atomic size. Radius of atom taken as a measure of atomic size, and it is the distance between a nucleus and outermost energy level. And its measuring unit is picometer, which equal part of million part of a meter. Look at the periodic table, which represents atomic size of some elements. We noted that atomic size decreases in a period by increasing atomic size and increasing group from top to bottom. Let's explain. In period, electrons increases by 1 in the same energy level, and protons increase 1 unit. So the nuclear attraction on electron increases and atomic size decreases due to contraction of the outermost energy level. In group, by increasing atomic number from top to bottom, there is addition of new energy level down the group. So the nuclear attraction decreases and atomic size increases. From all we said, we found that the largest atomic size is cesium and the smallest one is fluorine. Second property is electronegativity. It means how does atom attract electrons of chemical bond to itself. So we can say that electronegativity is the ability of the atom in compounds, molecules, to attract electrons of other atom of the chemical bond towards itself. We find that there is an inverse relation between the atomic size of atom and its electronegativity. Let's get it together. When atomic size decreases, its nucleus becomes closer to the electrons of chemical bond and attracts them easily towards itself. That means electronegativity increases when atomic size decreases. Look at the periodic table, which represents graduation of electronegativity. We noted that as we go up in groups by increasing atomic number, electronegativity decreases due to the increasing of atomic size we said before. But in periods, we find from left to right, by increasing the atomic number, the electronegativity increases due to the decreasing of atomic size. Now we will talk about the difference in electronegativity. When it is between elements of compound molecules, it determines the kind of bond, if it is ionic bond or covalent bond. So when difference in electronegativity more than 1.7, it's ionic bond, but if it is less than 1.7, it's covalent bond. On the other hand, when it's between elements of covalent molecules, it measures the polarity of these molecules and classified into polar and non-polar compounds. Polar compounds are covalent compounds in which the difference in electronegativity between their elements is relatively high, equal or less than 1.7 and greater than 0.4. But in non-polar compounds, it's equal or less than 0.4 but greater than 0. Let's take water molecule as an example for polar compound. It consists of combination of one oxygen atom and two hydrogen atoms. The ability of oxygen to attract the two electrons of the covalent bond towards it is greater than that of hydrogen because electronegativity of oxygen 3.5 is greater than that of hydrogen 2.1. Give reason. Water is considered one of the polar covalent compounds because the difference in electronegativity between its elements is relatively high. 3.5 minus 2.1 equal 1.4. Also, ammonia is a polar compound, but the polarity of water is more than that of ammonia because the difference in electronegativity between oxygen and hydrogen equal 1.4, more than that between a nitrogen and hydrogen, which equal 0.9. But methane CH4 and hydrogen sulfide H2S are considered as a nonpolar compounds, as the difference in electronegativity between their elements is a small value equal 0.4. Goodbye and wait for me for the next video.